Well, congratulations if you made it this far. I'm really glad you did. And this is the last unit. We're way on the downhill side. So um, I want to. This one they believe is easier than the last two. Um, it's. Anyway, I hope you find it easier. Um, So this is going to go in four sections. I got four PowerPoints, and my notes are posted, and the PowerPoints are posted, and the videos will be posted. Um, and like I said, I broke it up into four sections. The first one is not math, okay, but of course the following three are. So uh, it's not shouldn't be as long either altogether. But we'll see. Anyway, so welcome to Unit 5, Section 1, I guess. And we need to talk about sampling, okay? I don't know why I saved this till the end. I think it should have. Need to move it to the front somewhere. Anyway, that's my problem. Anyway, sampling, right? So, like to try to do research on an entire population, right? We define a population, whatever it is. So the population of the United States, right? Like, they do national surveys. Well, they don't send a survey to every person in the United States, right? They take a sample of people. And our hope is that we get to use that sample to describe the population then. And we're going to talk about that. So, because of money, because of logistics, right? Like, how do you reach? Even if I wanted to study the population of student body of Delta College, like to be able to reach every student is really not realistic. Or to get every student to reply, all those things, right? So it doesn't matter. Studying a population is challenging at best, right? But when we do study a population, what the data we get are called parameters, right? But mostly all of our stuff and what we've been doing is studying samples, right? And from samples we get statistics, right? That's what we've been talking about, right? If you have the right sample, the data is very viable. It's very reliable, like in being able to generalize that to the population. And so, but how you pick and work with samples is the thing. So, the thing with samples is we are really trying to eliminate any bias, right? And bias is whenever and one person in the sample, one person has a better chance of being picked for the sample than another, right? So anytime we anytime so there's a couple of examples of this. So right, so say I do a convenience sampling, right? So say I wanted to study the whole population of Delta College, right? But like I said, that's not possible. So instead, for my convenience, I just pick your class, your class. Well, the problem is you guys probably don't just, mirror the population of Delta College, right? There's not going to be like the same number of people in the age group from 18 to 25, 25 to 40, 40 to 50, right? There's not going to be the same amount of Hispanic clients, Hispanic students. There's not going to be the same amount as Asian Americans or Black or whatever it is, right? Chances are you guys are not proportional to the rest of the population. So it's just me. It's easy for me to just use you guys and survey you guys, but it's not a good sample. I hope that makes sense. The other thing that doesn't work very well is volunteerism, right? So there's a famous study. I'm not going to go into it, but I will. I'm going to use my own thing. So say I want to know about people's BMI, your body mass index, how much fat, what muscles, that kind of whatever. really don't even know exactly what it is. I just know my number's pretty good. It's barely good. Anyway, so what I do is I go into the local gym, right? I'm going to study the population of gym members. And so I go to one local gym and I set up a table and I ask people to come and volunteer their BMI. Well, guess what? The people I volunteer are people with good BMI. People with bad BMI that are way too high are not going to come and tell me what they are, right? That's the thing about volunteerism. It tends to get the people that are looking good, right, about the situation, right? The people that don't fit well or aren't looking good in the situation, right, don't come and volunteer that information. So that's the problem with volunteerism, and there's a lot of research, that goes along to show that that's how that works. So what we like to do is random sampling, and like the easiest, simplest, right? So if I want to take a sample of your class, right, I put everybody's name in a hat, and we just pull. So say there's 42 students in this class, and I want 20% basically, or so that's like 9 students. It's actually 8.4, but we'll take 9 students, right? So I throw everybody's name in a hat, and I just pull 9 people, and that's everybody had a fair chance of being picked, right, out of the class. Everybody had a chance. Now this goes a little sideways if one of those 9 people refuses to participate, and I have to pick another name, because now the pool is smaller, so the chances of being picked is higher. So more than we want to get into at this point, but needless to say, that's like pulling names out of a hat. If everybody gets a fair chance of being picked, right, that would eliminate some bias. So that's one of the things we can do. Also put in here about the random number table, and I don't think I loaded it. Anyway, we're not going to use this, but let me take a quick look. I think I screwed up and didn't load that. I'll put one in there for you to look at, but anyway, we have a random number table right now. Most that's on paper, right? So now mostly it's computer generated, right? It programs, you hit the button, and it'll pick the people for you, like randomly. So everybody has the same chance, and that helps eliminate or reduce bias. Like sometimes we just can't eliminate it, right? But we do our best to manage it and reduce it. And that's our goal. And so random sampling is one of the ways we do that, using a random number table. There's another way to do that, right? And so we've talked about this a lot. You just didn't know we were talking about it, right? So we have sampling errors, right? So we've been talking about the null hypothesis, and it says, right, that there's no difference between the means, between groups, right? And that's the theory. If you study the whole population and men and women, then there's no difference between the mean of the men and women. And the null hypothesis further says that anytime there is a difference, it's based on sampling error, right? And the sampling error comes from bias. It comes from several different things that we don't really need to get into here. Okay, so that's why you've been doing all this with the critical values and the 0.05 level, the 0.01 level, right? Because we are willing to accept a certain percentage of error, margin of error, right? And so we said the standard is set at the 0.05 level. So we're willing, if we can be right 95 times out of 100, and we're only going to be wrong, possibly be wrong at the most 5 times out of 100, then we would consider that reliable, viable data, okay, to generalize to the population. So So a lot of things come into sampling, right? So if I'm taking a sample of all the population of students at Delta College and I start with a sample of 100 people, that's right. So if I increase that to 200, then that makes a significant difference, right? Um, Doubling that size, that makes a significant difference in the kind of data I would collect. Meanwhile, say I had 3,000 students and I just added 100, 3,100, that's not going to have the same kind of impact as it would as going adding 100 to 100, coming with the 200. That makes sense, right? So increasing the size of the sample can make a difference, but not always. Yeah. The other side of the coin is if the less variability in the population, meaning if I pick a population that's, let's say, I pick a community and everybody in that community has a college degree and everybody in that community is a Democrat and everybody in that community is makes $50,000 to $75,000 a year, right? So they have all these commonalities, so they're much more similar, right? There's not that much variability in the population when if you look at reality, right, of our population of Stockton, let's say that's it's a wide variety of all. Those people have a lot more in common, and so that makes it easier. Like when you pick your sample, it's more than likely they're going to represent the rest of the population. And like I said earlier, there's a lot of national surveys, television, food, like all kinds. And they really only use like 15 to 1,500, 2,000 people to represent the population of the United States, which is like 200 plus million. So if you pick the right, and they get viable, reliable data, right? Because they're using it to project their money, project sales, project elections, all that kind of stuff. And with that small of a sample, they can still get very reliable data if they do the sampling in the appropriate way. So sometimes, like this is just a weird, I don't know why I picked this example, but we have a thing called quota sampling. So I'm the potato chip company and I want to know out of the new flavors I got which one people like the best. And so rather than figuring it all out and doing all my sample, what I'm going to do is find another food sample, another food research study, and I'm going to match that sample by numbers. Meaning, if I have 100 people under the age of 18, then I'm going to want 100 people under the age of 18. If I have 100 people that are Hispanic, then I'm going to want 100 Hispanics, right? So I'm going to match that and do a quota, what we call a quota sampling, right? So I'm going to match the population either exactly or in percentages, right? But I'm going to match that population of a population that has already provided reliable and viable data. Most of this you don't really have to remember except for the exam, and if you keep going, you're going to get a whole lot more of it, so don't worry. And then we can do, so that's quota sampling, and then we can do like stratified random sampling. Okay, so we have a group, let's say, of men or women, athletes, musicians, whatever, and we decide. So now we're going to study all the colleges. We want to study to reflect all the college students in the United States. That's not going to happen, right? Well, like I said, it would be almost impossible to get all the Delta students. So we would break that down into groups, right? And we would take, so we would decide like, okay, we're going to use all the people, all psych majors, and then we're going to use just freshmen and or sophomores or juniors. Like we can break people up into groups, and then we would do that, and that's like what we call stratified random sampling, and it leaves us layers, which are right? The other thing we can do, which is very similar, is called cluster sampling. So I want to study all the soccer players in America, and then what I would do is look at all the leagues, right? First I would look at all the leagues, and then I would pick out of those leagues. So say there's 1,000 leagues in the United States, I would take those 1,000 leagues, and each league has 10 teams, and these are ideal situations, right? So then I would pick one team out of every league, and right, and so then how many would I end up with, right? So 1,000, and right, so I would end up with like 100 teams, let's say. But that's not, so if I do cluster strategy, and each team has 20 people, let's say. I don't know how many people are actually on the soccer team. I think I would, I'll watch it all. At any rate, but N in this case is not the number of subjects anymore. N would be the number of clusters, right? And so here I said 10. So here I wrote 20 in the notes. At any rate, you just need to know some of this for the test. There are some questions, not a whole lot, but this is sampling, and this is the end of the first section or unit, section of Unit 5. Okay? As always, I'm available if you have questions. Please feel free. All right, we're going to move on now. Or you can choose to move on when you like.